Hello guys, and welcome back after the break. So basically we're looking at 2.2. Now the examiner provided you with a cross section from one point to another point. Now what's a cross section? It's a size profile of the land area. Now as you can see, the side profile. Now very importantly, when we look at the cross section, it consists of a vertical scale, that's usually the meters, and the horizontal scale. The horizontal scale is the map that you use. In this case, the examiner used the topographical map. Now, if the cross section was drawn on the orthophoto, the horizontal scale would have been 1 to 10,000. But it's 1 to 50,000 because he used the topographical map. And your vertical scale is your vertical line representing the height. So in this case, 1 centimeters represents 20 meters. Now the next question states, calculate the vertical exaggeration of the cross section. Now first of all, have a look at your formula. Vertical exaggeration equals vertical scale over horizontal scale. Now both have been provided for you. Your vertical scale is 1 to 20 meters. So it means 1 centimeter represents 20 meters. And your horizontal scale is 1 to 50,000. But remember, we're working with centimeters over here because 1 centimeter represents 50,000 centimeters on your horizontal scale. So we need to convert that 20 meters to centimeters. Now, how many centimeters is there in 1 meter? There is. How many centimeters is there in 1 meter? 100. Now, how many centimeters is in 10 meters? 1,000. Now, if you look, what's the vertical scale? 20 meters. How many centimeters is going to be in 20 meters? 2,000. So our vertical scale is 1 to 2,000, and our horizontal scale has been provided for us. 1 to 50,000. Now we need to divide the vertical scale through the horizontal scale. So it's 1 over 2,000 times 50,000 to 1. That leaves us 50,000 divided by 2,000. And if you quickly take your calculator and do the calculation, 50,000 divided by 2,000 equals 25 times. Now identify the feature labeled X and Y on the cross section. So basically what we need to go and have a do, the cross section has been drawn from the tree station 184 and E6 to the windmill in E4. Now let's just quickly go and have a look if you can find it. E4 to E6. One, two, three, 4. There's the windmill. Just want to make 100% sure. This is E4. So this is the windmill over there to the Trich beacon 184. So that is where our cross section was constructed, from there to there. Now they ask us at point X, identify what we see over there. What do we see over there at Y? Now as you can see, there's a power line situated where Y is, and definitely we can see cultivated land where X is. So let's just quickly fill in our answers over here. If we look at X is cultivated land. And Y was a power line. Now, how do I know it's a power line? I just want to go back and quickly explain that to you. There's the power line. As you can see, it's a solid black line with little circles in it. Once again, please, all the information that you need is on your map. And there you can see there's a provincial boundaries over there, and your information regarding the power line will be, there's it, as you can see, a power line. So all the information that you need is basically on the map. Just go and look for it and look at the reference that they use so that you need to know what it is. Okay. Now the next question, why do we use vertical exaggeration and why are cross sections exaggerated? Because it shows us the height to see the difference in height. Now keep in mind, when we look at the cross section, there can only be two horizontal scales, and that depends on the examiner if he asks the cross section on a topographical map. And if the question is on a topographical map, the horizontal scale is going to be 1 to 50,000. If it's going to be on an orthophoto map, your scale is going to be, horizontal scale is going to be 1 to 10,000. The vertical scale can be anything from 1 centimeters represents 20 meters, or 1 centimeters represents 40 meters, and even 1 centimeters can even represent 50 meters. Okay, so make 100% sure. Remember, don't get confused between vertical scales and horizontal scales. If you look at horizontal scales, keep in mind the sun comes up on the horizon, and vertical is upright. Okay, now let's continue with our questions. Calculate the magnetic declination for the year 2011. Marks will be allocated for calculations. Now matrix, pay 110%, make 110% sure that you read the question correctly. The question states to calculate the magnetic declination for 2011. Do not go and calculate it for the present year. They ask you to calculate for 2011. Now, where do I get all this information from? From your topographical map. Let's go and have a look. Down the bottom, right in the middle, between your two references, there you go. It shows you the mean magnetic declination is 23 degrees 33 minutes west, and it was taken in 2002. It means every single year it changes 6 minutes west. Now if we move west, we're going to add up in the end of the day. We do not use that date, 2000, 2005. Only the date of 2002 is important to us. So they ask us not to calculate the present magnetic declination, but the magnetic declination for 2011. So that's going to change things a bit. So let's go back to our question. Now first of all, they ask us to calculate the magnetic declination, and the magnetic declination is 23 degrees. The magnetic declination for the, just want to check this out, for the pole map is 23 degrees 33 minutes. 23 degrees 33 minutes. And this map was drawn up in 2002. And we know the annual change was 6 minutes west. Now keep in mind, when it's west, the change, we add. When it's east, we subtract. Now, first thing, we need to calculate the magnetic declination for 2011. So what do we do? 2011 subtracting 2002. And that gives us, use your calculator before you make a mistake, 2011 subtracting 2002, that equals 9. Now, because the annual change is 6 minutes west, now the map was drawn up in 2002 and up into 2011, 9 years has passed. So you say 9 times 6, and that equals 54. Let's just make 100% certain. 9 times 6 equals 54. So that's 54 minutes. Now, because we're moving west, what do we need to do? We take the 23 degrees, 53 minutes, plus we add 54 minutes. Now remember, 1 degree equals 60 minutes. So let's quickly add just the minutes. 54 minutes plus 33 minutes equals 87 minutes. Now 87 minutes equals 1 degree and what's left? 60, 70, 80, 27 minutes. So what we can say over here is 23 degrees plus 1 degree, 27, equals 24 degrees, 27 minutes west. And that's our correct answer. Please don't get confused with the minutes and degrees. Remember, 60 minutes equals 1 degree. Okay, let's move forward. Give 2 reasons why the magnetic declination will be useful to a person using a map on a field trip. Now, first of all, it determines true north. Because unfortunately, if you use a compass, it shows you magnetic north. And secondly, is to reach a destination using a compass. Okay, so another reason that we can add over here, because we can also, with the magnetic declination, calculate the magnetic bearing, very importantly. Okay, let's quickly go and have a look at our next set of questions. Question 3 is the application of the theory. So what you've learned in climate and geomorphology, as well as settlement geography and economic geography, can be based on the map itself. So we can go and have a look at what type of activities are taking place, for instance, in Pole, what type of activities are dominant in the area of Pole. Now let's say, for instance, we had a map of Johannesburg. Obviously there's not going to be much rural areas, but it's going to be an urban settlement, and it's an urban area because it's classified, it's multifunctional. We have activities like secondary, tertiary, and quaternary activities. But let's quickly go and have a look at the questions regarding the topographical map and the orthophoto map. Now, if we look at the first question, identify the shape of the town Pole. Let's quickly have a look at that. Now here where the orthophoto has been taken, the demarcated area. As you can see, there's Pole. Now, as you can see, this is the CBD, Central Business District. Now, one thing that's certain is definitely in a linear shape, situated next to the Berg River. Look how it stretches from there all the way to up there. And on this side, what do we have over here? The Pole Nature Reserve. As you can see, we have the massive granite domes on the one side, and the other side we have the Berg River. So do you agree with me that it's a linear shape? Definitely not a round shape, but linear in shape. So So if you look at the question, 3.1.1 is definitely a linear shape. Name 2 physical factors that determine the shape of the town. So we just looked at it. On the one side, we have this massive pole rock, the granite domes. It's a batholith that's being exposed because of weathering and erosion. And on the other side, we have the Berg River. And that's the reason why the infrastructure is linear in shape, because to fit in between the two areas. They can't build on the steep gradient because it's too expensive. And obviously they can't build further down the valley because that's where the river is. So the correct answer will be the town developed next to the Berg River and we can also say it developed next to the mountain range. Tula. Okay, if you look at question 3.2, what is the direction of the Boland Agricultural College and block C7 from Paul? Okay, it's in C7. Let's quickly go back to our map. Now there's the Boland Agricultural College, as you can see. Now the question states there is Paul. I just want to place my finger and you can see where it basically is. There's the Boland College and there's Paul. What direction do you think the question states? What's the direction of Boland Agricultural from Paul? Now Paul is over there, north will be situated over there, east, south, west. So the direction from Paul to the Boland College will be northwest. And will also accept west, northwest. After the break, we're going to continue with some more questions. Don't go anywhere. See you in a bit.